Oke, Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, Salam Sejahtera bagi kita semua. Introduce myself. My name is Rohana Prangangin. I am a final year student of the Electrical Engineering Study Program at Medan Area University. I would like to export my defense graduate to the International Conference on Advanced Information Scientific Development 2023, institution which has given me and my team the opportunity to carry out a presentation today. Okay, I'll just start my presentation today. Smart plant protection technology in hydroponic CD plants based on IoT to prevent failure due to pests. Okay, next. Abstract. The design of the smart plant protection is an IoT-based technology that can assist the community in caring for and monitoring their plants digitally. This tool can also make it easier for the community, especially vegetable farmers, to spray digitally even from a great distance from the garden. The technology, the technology has been equipped with a camera sensor that function to monitor the condition of the silly plants in real time and with accurate result, which is partners can monitor silly plants using Android even though partners are far from the silly garden. In this smart plant protection designs, the tool needs include ESP 8266 as a microcontroller ESP32CAM as a real-time monitoring camera, two-channel relay as a pesticide pump control, and easy sensor as a digital detector of ppm value of nutrition. The sensors are pump integrated through a microcontroller so that they can provide data via the Android application. All components are integrated so that this technology is expected to facilitate the work of more modern vegetable farmer. Okay, next. Introduction. Chili plants are one of the horticultural commodities that have a fairly high selling value at this time. Chili is one of the plants that is very easily attacked by pests. Especially, chili plants grow hydroponical. Chili plants are usually attacked by plant pests, namely armyworms pests. Therefore, this is what makes farmers have to take very extra care to get maximum chili plants fields. But actually, controlling silly plants directly is not easy to do. Not only the time of spraying pesticide is the benchmark for planning success. Silly trees, but quite extra control must be carved out on these hydroponic silly plants. The impact if the hydroponic silly tree is attacked by pests can cause the silly leaf and fruit to dry, so that they cannot be marketed. Okay, therefore farmers have to be even more extra in taking care of these hydroponic silly plants. This is very difficult for most farmers to realize because the silly plants themselves must be monitoring regularly and must be sprayed pesticide at least at once a day. Technology development are currently changes human life to be more modern and more practical, of course. One of them is the use of tools that are used for monitoring and controlling silly plants easily and can be controlled anywhere without having to be at the plantation location. Plantation farmer can easily get information about their gardens, especially silly plants in real time, so that the farmer also know the condition of the garden land and can handle it properly from a long distance. Okay, next. Monitoring the conditional of silly is one of the most important things to do. The goal is to get maximum silly result. Therefore, the purpose of this activity in monitoring is to find out the population of pests on silly leaf as well as the ppm value of nutrients contained in silly water, which must be monitoring regularly because the two things are related to the growth quality of the hydroponic silly plants themselves. Currently, many people in the city of Medan have implemented their own plantation using a hydroponic system to meet the needs of household kitchens. And it is possible that there are still many Medan city people whose livelihoods are as hydroponical vegetable farmers. Currently, hydroponic chili cultivation has been widely early out in urban areas because the price of chili in the market is quite expensive. It is estimated that the price of chili in 1 kilogram is easier 100,000 in the market. The city hydroponic system is in farming technical that does not require soil as a plantation medium. Currently, agricultural land in urban areas, especially in the city of Medan, has decreased significantly due to the many infrastructure development activities in urban areas that have turned agricultural land into residential land and industrial land. With this, farming communities are advised to use the hydroponical method as a solution in overcome limit land for plantation, as well as overcoming reduce agricultural land by using unusing or untied place in urban areas such as those that can be applied on roof of the house building. Okay, next. Monitoring the condition of hydroponic plants is generally carries out by paying attention to information related to nutrition and the need for pesticide to prevent pests on chili plants. This information also does not present the real condition of the chili plants physically. So observation and supply of pesticide must be carried out direct on the chili plants area. This result will create a system for monitoring and controlling the condition of chili plants in real time by sending image data sent via IoT with the ESP32 CAM module, pesticide spray and edge sensor, or electrical conductivity sensor. The image data will be stored in an application so that the condition of the plants can be monitored during the planting period. This tool is also equipped with ESP 8266 microcontroller, which is used to transfer data from sensor with the IoT concept. IoT itself is a concept that aims to expand the many benefits of internet connectivity that can be connected continuously using a wireless internet network. Okay, with the application of IoT in monitoring chili plants, this hydroponic system can make it easier for farmers to do gardening even from a great distance. The performance progress is this system also requires a community device that can transmit monitoring result of hydroponic chili with the NFT system in real time to provide action to overcome these problems even from a very long distance. The design of smart plant protection technology itself, it is modern technology that can help farmers to monitoring and controlling plants, especially FD hydroponic plants in real time. The advantage of this tool is that it can be controlled easily even though it is very far from the plants, and at the same time provides a reciprocal action on the sensor when the resulting output does not match the input progress. Okay, next. Proposed feature, effort transfer and future extraction. The research was carried out using the literary study method and a survey of problems found in the Medan City community directly. The research method was carried out by conduction location survey, direct observation of one of the well-known hydroponic garden owners in the city of Medan, and there are many types of plants that have been grown through the hydroponic system. One of them is the hydroponic chili plants, which is have several problems in their maintenance, where the hydroponic chili plants themselves have to do very extra care to get good and abounded crops. The stakes of this research include a literature study and observational survey based on the problems experienced by a fairly large hydroponic chili plantation in the city of Medan. By carrying out the progress of making smart plant tools that have been equipped with several sensors that support to overcome these problems. Furthermore, in this study, testing the tools that have been designed directly on the NFT system hydroponic chili plants. The tool design progress used three layers, where the layers consist of application, network, and profession. In this stage, a design is carried out, namely the design of a software or hardware. The expected output at this stage is to obtain a hardware design, but a circuit block diagram based on the electronic components that have been obtained and a software design obtained is accordance with the flow that has been made. The following is a block diagram of the system and 3D tool design based on figure ones. Okay, next, design. In the picture above, you can see the working principle of the ESP32 cam sensor, which function as a monitoring of the NFT system hydroponic chili plants. The function of the ESP32 cam is that it is used to get an overview of the chili condition in real time, so that the chili plants can be monitored in real time through an application. Okay, in addition, there is an AC sensor or electrical conductivity sensor that is used to check the ppm value in chili plants digitally and integrate via the internet, which is controlled automatically, and there is a relay as a switch to turn and turn off the spray nozzle connected to the pump. Then the 3G design aims to describe the layout of the tools to be installed in the NFT's hydroponic system. The tool design progress will use three buckets of water. An explanation of the first bucket containing vegetable pesticide in which there is a water pump, and a second bucket containing water flowing into the pipe of the NFT hydroponic system. And the three bucket containing IB mix nutrients that have been paired with HA sensor. When the HA sensor detects the ppm value and the second bucket is smaller or 500 approximately ppm, the pump in the three pipe will automatically add nutrients into the second bucket slowly until the nutrients in the second bucket uh, reach more than 700. Okay, next. Yes, and furthermore, the design of the tool is carried out so that the growth of chili plants can be monitored from a very long distance, and the maintenance is controlled from a very long distance. It is application that provide maximum chili yields and makes it easier for hydroponic chili farmers to carry out maintenance only via mobile phones. Monitoring and controlling chili plants can be done anywhere and anytime without any time limit while there is still a smooth internet network. The following is the design of a three layers architecture, secret, and will based on figure 2. Okay. In design this tool, three-layer IoT architecture is used, which consists of application, network, and perception. The application itself uses the Blink IoT application, which has several features, such as a live broadcast screen feature integrated via the ESP32 cam sensor, a pass button to activate the spray or spraying pesticide on plants digitally, and cow display the ppm value of water integrate with the easy sensor. Then the electrical circuit schematic in the design of electronic circuit in this system is that an application is needed that is able to describe the components of the system so that from the appropriate application and load with the availability of all components need the freezing application is used. Okay, next. Okay, data and experimental setup. Tool setting is carried out on jelly based so that all components and sensor used can work based on the reliability of the tools to be used. Then testing the integrated ESP 8266 microcontroller with the aim of getting the target ppm value and achieve the ppm nutritional value in hydroponical silly plants. To see the result of testing the ESP 8266 sensor and microcontroller which have been operating when they reach the time specific in the test based on table 1. Okay, can be seen in the image below. Okay, next. Next, result and discussion regarding the implementation of the tool with the concept of building an IoT architecture using 3 layers, which consists of the ESP 32 cam sensor, which is used for monitoring hydroponic chili plants. In addition to, there is an electric conductivity or EC sensor that is used to check the ppm value of the nutrients in water, as well as a nozzle spray that is used to spray pesticide directly on hydroponic chili plants. The hardware sensor is integrated through the MCU ESP 8266 microcontroller, which will be connected to a Play Store application which can be downloaded directly for free. The application is playing IoT to monitor and control through the network or internet network in real time, so that the result of making this tool maintenance and control of the hydroponic chili plants with the NFT system are well realized, even though the farmer are very far away. Okay, can be seen in the image below. Number 1, nozzle spray tools. Number 2, GDS sensor display, and number 3, monitoring sensor display, and number 4, ESP 8266 display. Okay, next please. Next. Okay, output figure 3 of overview of the tools. A from tool impact, real to impact, silly free test result. In the tests that have been carried out at this stage, the aim is to describe the result that have been obtained using the ESP 8266 microcontroller and sensor that have been installed when the tester research the specific time. Okay, next. Conclusion. Based on the result that has been done, it can be concluded that monitoring and controlling chili plants using the ESP 8266 microcontroller and ESP 32 cam sensor. Each sensor, relays, and nozzle makes it easier for farmers to carry out maintenance only even though the farmer is very far away. By spraying pesticide regularly, which is 2 times a day, you can prevent caterpillar pest attack on chili leaf. Therefore, by installing a nozzle that is integrated by the relay and ESP 8266 as a control, pesticide irrigation can be done digitally using the Blink application. Implementation the tool by using the TDS sensor on chili plants with the NFT hydroponic system. Farmers can find out what the ppm value is contained in the water and don't need to add nutrients directly to the plants. Adding nutrients automatically through a pump location in the water reservoir can maintain the ppm value at the desired value position. The relay itself is used and electric switch that function to disconnect from the electrical supply to the spray nozzle and nutrient pump. Okay, next. Next, acknowledgement. Thank you to Kemendikbud Ristek for funding support for publication through Student Creativity Program or PKM in 2022 and full support from the Electrical Engineering Study Program and Medan Area University. Okay, that's all my presentation this time. If there are mistakes, I apologize. I say goodbye. Thank you very much. Okay, thank you. Udah bang, udah siap? Nick, udah siap? Oke.